ways, and hopefully you'll see the connection between all of the different ways. So first I'm going to draw 1 1/4, hopefully not too poorly. 1. It's about the same. Okay, 1 1/4. In order to do quarters, I do halves and halves, and I pray that it looks close enough to correct. So here's my 1. 1/4. See, and I'll zoom in a little bit. 2/3 times 1 1/4. So there's 1 1/4. And we need 2/3 of that 1 1/4. So I'm going to say that my 1 1/4 is the orange. Then for 2/3 of that, I'm going to do that kind of a purpley. Okay, hopefully you can see that. So for 2/3 of 1 1/4, I'm going to do the thirds this way because that's how we've been doing all of the multiplication. So I'm going to try to make this be thirds, try to make this be thirds, but it's never really all that perfect. I try. 2/3 of 1 1/4. So I've got the 1 1/4. I broke it into thirds. I'm going to shade in 2 of the thirds. 1/3, 2/3 of 1 1/4. Okay. So, Abby, this is the one you asked for. Do you see in the picture the purple 2/3 of the orange 1 1/4?
Yes, the pictures make sense to me. It's like I'm more concerned about the actual math.
Right, and now I'm going to connect all of it. First, I'm going to make the picture make some sense. This part of the picture, you've got a 2/3. And this part of the picture, what do we have? How many pieces altogether is this bar broken into now?
12.
12ths. So we've got 2/12ths here. Okay, and all together, when we add these, first we're like, ooh, this looks yucky to add. So what we're going to do is we're going to deal with the fact that this was in 12ths and that was not. So let's go ahead and do that, which is this. And then we can see that we're really adding 8/12ths plus 2/12ths. And what do you get?
10/12ths.
Okay, and so the 10/12ths is also in the picture, but it's kind of weird, and this is not at all intuitive. So I'm going to do it the 2 different ways that Gabby asked about in her discussion board post, and hopefully answer what you were asking. So there's a couple different ways that you would do this by hand. The one that you would traditionally do is 2/3. You change this to a mixed number. So we've got 4/4 plus 1/4. So we do this times 5/4. This is the traditional mixed to improper and then multiply. Okay, and that would right away give you that 10/12ths. Okay.
Professor?
Yes.
How did you get the 5/4?
So for 1 1/4, 1 1/4, for 1 1/4, that 1 is really 4/4, and then 1/4.
Okay.
So I did that. What I really, oh, sorry, that was above the screen. What I really did is that trick that I hate you guys that you do, was I did 4 times 1 plus 1. But the 4 times 1 is because there's 4/4 in the 1, and then there's one other fourth. Thank you for asking.
Would it be wrong if we did that, or did we have to kind of visualize the way you drew it?
If the visualize the way that I drew it up here, that's if I'm only asking you to convert from a mixed number to an improper in a meaningful way. If I'm just asking you to compute something, it's totally fine if you do it however you need to do it. Does that make sense, the difference between those two?
Yes.
Okay. All right, so, Abby, this is the traditional way. And you were asking, can you do it in a different way, right?
Yes. I was wondering if you could do it without making the improper.
And this will tie into every single thing that you've asked me about the whole little fraction things, and I think it'll be really good for you. So, that's traditional old way. This is such a slobby mess all over my paper. So, the other way to look at it is 2/3 times 1 and 1/4 is really the same thing as 2/3. I'm going to make it bigger over here. 2/3 times 1 and 1/4. And 1 and 1/4. It's so funny to me how mixed numbers are written, because they're right next to each other. We know what it is, but why is it that? Why, because usually when you have two numbers next to each other, that would mean multiply. This doesn't mean 1 times 1/4. It means 1 and 1/4. So to do that, you can do this 2/3 times 1, which is the 2/3. That doesn't look like a third. Plus 2/3 times 1/4 using the distributive property. And 2/3 times 1/4 multiply across 2. Actually, let me slow down a little bit more even. 2/3 times 1 is the first thing I did, and then 2/3 times 1/4 with the distributive property. So that gives us the 2/3 plus 2/12, which looks yucky, and we're going to add fractions, which we haven't even done yet, right? What do we need to do in order to add fractions?
Find a common denominator, which is
Find a common denominator. Yep. So we do this, 4/4, and then we get 8/12 plus 2/12 equals 10/12. So it's definitely kind of ugly, but it literally is showing what you did in the fraction bars. This distribution, 2/3 times 1, is this piece right here. 2/3 times 1/4 is this piece right here. So do you kind of see the connection between the picture and this distribution process right here?
I think so.
Okay. And this is recorded, so I'll try to hopefully make it clear what it is that's recorded. And this is the precursor to understanding that FOIL thing that you were asking me about earlier. So I feel like if you process this some more, you'll be able to get to the FOIL thing that you asked me about.
Okay, I watched the video and it makes more sense after class also.
The FOIL one?
Yes.
Okay, and all this is like a piece of the FOIL, because the FOIL is distributing first, inner, outer, last, or outer, inner, last. And this is just a single distribution. So it's actually, this is just a simpler version of that. It might be useful for getting to there. So, I'm trying to think. And the other thing I guess I should do, if you guys can process a little teeny bit more, is 10/12 isn't really, so this is, the way it is, this is like fine, except that we wouldn't usually leave something as 10/12, right? What would we do?
Reduce.
We would reduce, right? So 10/12 is really, I'm going to do this all in green, is really 2 times 5, and I'm not doing prime factorization, I'm doing just the thing that's going to cancel. 2 times 6, and then the 2's cancel, and then we get 5 sixths, and what I'm going to get at here is where that happens on here, and you may or may not be able to see this. It's going to be really not super easy to see, but I'm going to try. Okay, so if you can still process a little bit more, the 5 sixths I'm going to show you relatively quickly on here. It's not going to be beautiful, but I'm going to try. So since these are now in 12ths, there's a couple different ways to show sixths, but I'm going to show them. Here's one of the sixths, and I think you'll be able to see them all. Here's one of the sixths. Here's another of the sixths. Another sixth. Another sixth. Another sixth. Okay, these are the 5 sixths. So there's, and I'm going to make these lighter. So there's 1, 2, 3, 4, and then 5 out of, I'm going to try to draw these. This piece right here, even though it doesn't look beautiful and perfect, if this hole right here was like a cake or something we were sharing, I keep sharing cake, and there are 6 of us in the room actually, so if we had to divide this cake into sixths, we could, and my drawings were better, this piece, this piece, this piece, this piece, this piece, and this piece would all be equal sizes. So this is now showing the reduction a little bit. I would not expect you to really do this with like elementary students, but I feel like you guys maybe can see it. So here, rather than making it into the 12 pieces, if you subdivide it so that, rather group it so that you're taking 2 of each 12ths to make sixths, you can see 5 sixths a little bit. That's pretty hard to see. Could you guys sort of see the sixths?
I can sort of see it.
Yeah, because
it's not pretty. You wouldn't have made sixths that way naturally, but
2 12ths equals a
yeah.
sixth.